Hey folks, today we're going to be working with something called compound angles. And all compound angles are multiple angles in the Cartesian coordinate that have either been added or subtracted together. So like here we go from 0 up to this value of theta, that's our b value of theta. And then look, this arc continues to a. If we wanted to find out the leftover in here, the way we would do that is we would take the whole A angle and we would subtract the B angle to give us this leftover. So this is the kind of stuff we're going to be doing today. The compound, remember how to do all of this stuff with the liner. Here we go. Here are compound angle formulas. You don't have to memorize these. These are going to be provided for you. But you do have to decide, am I going to be using an addition formula or am I going to be using a subtraction formula? And once you figure out what the formula you're going to use, you basically just plug in information to here. Kind of like our quadratic formula, kind of like um, sine law, cosine law, all that stuff. We just plug it in and solve. So cos, we're dealing with a cos. We're either going to be doing cos A plus B or cos A minus B. When we're trying to find values that say exact, that tells you we need to use special triangles. And what we need to do is we need to break up this 15 into two of our special triangle values. Like 1 plus 14 would give you 15, but neither of those are in our special triangles. 5 plus 10 would give you 15, but neither of those are our special triangles. Remember, our special triangle are the 30, 60, 90 triangle, or the 45, 45, 90 triangle. So can we get the number 15 from a combination of these two values, any two of these values? Well, we can't add any of them. Like 30 plus 60 would give us 90, 30 plus 45, 75. Like if you were to do any of the additions, A plus B, we can't get to a 15. So we're going to have to use this cos subtraction one. It's going to be a subtraction. And if we used 30 and 45, we could subtract those two values to get a cos of 15. So cos of 15 is actually going to get broken up into, oops daisies, cos of 45 minus 30. 45 minus 30, 45 is a special triangle, 30 is a special triangle. That would give us 15. Now, we just replace the A with our first value and the B with our second value, and we write out this equation. So cos A, cos B, sine A, sine B, and it's a plus even when it's a minus. Okay, so, whoops. So cos A, cos B, I don't have enough room. I take it and move it over there. Okay. No, wait a second. It's a plus in between. Okay. Plus, and then it's a sine A, sine B. Okay. Sine A, A, B. Sine of A times sine of B. Oh, what are my triangles? There's one triangle. That's 1, 1, root 2. Then there's another triangle. Whoops-a-daisies. These are obviously not to scale. Then there is, so that's a 45, or I believe it's pi over 4, right? Pi over 4, okay. And then I've got a 30 degrees, which is pi over 6. And opposite the pi over 6 was the 1. And then we had 60 degrees over 3. Opposite the pi over 3 was the root 3. And then that's a 2. Okay, okay. So, cos of 45 is adjacent over hypotenuse of 45. Adjacent hypotenuse, 1 over root 2. 1 over root 2 is cos of 45. Cos of 30 is adjacent over hypotenuse from 30 angle. Adjacent is root 3, hypotenuse is 2. So root 3 over 2. Then we can do some math. Plus sine of 45 is opposite over hypotenuse, 1 over root 2. And sine of 30 is opposite over hypotenuse, which is 1 over 2. 1 over 2. Okay, now it's just straight fraction multiplication. Top times top, bottom times bottom, top times top, bottom times bottom. And if we're lucky, we're going to end up with an expression that has a common denominator. Sometimes we're lucky, sometimes we're not. So 1 times root 3 is root 3. 2 times root 2 is 2 root 2's. Plus 1 times 1 is 1. Root 2 times 2 is, yes. Denominators are the same. If the denominators are the same, we can add them together. Root 3 plus 1 over 2 root 2. Not finished because we do have to rationalize the denominator. Instead of multiplying by everything that's in the denominator like we did for the other ones, we're just going to multiply by the radical because that's the value that we want to get rid of. Okay, I need to remember my multiplication meters. There are 2 things up here, so this root 2 has to go into both of those things. And then in the bottom, extend the page, move this down. Root 3 times root 2 is root 6. Radicands multiply each other. 1 times root 2 is root 2. Can't add those. Those are not like terms. Then this 2 is going to go straight down. It still lives there. And then root 2 times root 2 is root 4, which is just 2. So it's going to be 2 times 2 in the bottom. Can I simplify any of these? Root 6. There's not a square rootable number in there. There's not a square rootable number in there. And then there's just a 4. Done. I think that's enough for my first video.